Homework 11, question 2. So question is saying, it is suggested that the following function of V may represent an autocorrelation function of y-stand stationary stochastic process by setting V is equal to tau, or a spectrum density function by setting V is equal to omega, or both. So question provides us three functions that's asking which functions f of V may represent either of those or maybe both. So we know that if r of tau is going to be equal to an autocorrelation function of a real WSS stochastic process x of t, then it must be even, and r of tau is going to be smaller or equal to r of 0. And we know its Fourier transform is a non-negative. Also, we know if the S omega, which is the spectrum density function, a power spectrum density function of a y-stand stationary process x of t, it must be a non-negative as well. So so f of v is going to be equal to the e to the negative absolute value of v. So for this one, we know that you might represent the autocorrelation function because we know the e to the negative absolute value of v must be even, and we know that e of negative absolute value of v is smaller or equal to e to the negative 0. So when we do the Fourier transform, we get that e of negative v is going to be equal to 2 alpha over alpha squared plus omega squared, which is a non-negative function. So it could be an autocorrelation function. Also, it also might be a power spectrum function, because we know that e to the negative omega, absolute value of omega, is going to be equal or bigger than 0. B, f of v is equal to sine v squared over v squared. So we know for the autocorrelation function, it might be represent the autocorrelation function because we know the sine tau squared over tau squared is even, and we also know that the sine tau squared over tau squared is going to be smaller or equal to the limit when tau goes to 0, sine tau squared over tau squared, which is going to be equal to 1. And we do the Fourier transform for that function. As we see on the graph, it shows this function is actually it's actually a non-negative function. So because of that, we know it could be represent the autocorrelation function. B, it could be a power spectrum function as well, because we know the sine omega squared over omega squared is going to be bigger or equal to 0. C, so f of v is going to be equal to 1 when the absolute value of v is smaller or equal to alpha, and then it's going to be equal to 0 when absolute value of v is going to be bigger than alpha. So for the first one, we know it cannot be an autocorrelation function to the function because we know its Fourier transform is going to be 2 times the sine alpha omega over omega, which is not a non-negative function. So it cannot be an autocorrelation function, represent the autocorrelation function. B, it could be a power spectrum function because we know the f of omega is bigger than 0.